Hi, we're Airforce Joes, and these are the four forces of flight.
What is the physics behind flight? There are four forces acting on all aircraft in straight and level unaccelerated flight: thrust, weight, drag, and lift. Thrust and lift assist flight, while drag and weight oppose it. Let's start with weight. We'll call this m, that is, the mass of the aircraft itself and everything it carries, times g, the force of gravity, which on Earth we take to be 9.81 meters per second squared, or 1g. The weight of the aircraft does not change, but the load it carries can become lighter as fuel is burned during flight. Lift is required to counteract the aircraft's weight. In level flight, when the lift force is equal to the weight force, the aircraft is in a state of equilibrium and doesn't move up or down. If lift becomes less than weight, the plane will descend. When lift is greater than weight, the vertical speed will increase. Lift is defined as the force of the aerodynamic effect of air acting on the airfoil. Let's consider Bernoulli's principle. Air under high pressure in a venturi travels slower. The curved surface of the airfoil is essentially half a venturi and forces the air on top to travel quicker, reducing the pressure. Conversely, under the wing, the air is traveling slower, creating a high pressure. This difference in pressure creates the upward force known as lift. When this lifting force overcomes the opposing force of weight, we get flight. The pilot can control lift. By moving the yoke fore or aft, the angle of attack is changed. As the angle of attack increases, so does the lift. When the aircraft reaches the maximum angle of attack, lift begins to diminish. This is known as the critical angle of attack, and stall occurs at this point. However, lift cannot be generated unless it is continually forcing air down the wing, and therefore must continue moving forward. We can then say that lift is proportional to the square of the aircraft's velocity. In other words, doubling the airspeed will result in 4 times the lift. Looking at the formula for lift, we can see it wouldn't be possible to maintain the same angle of attack at a constant altitude if the velocity is increased. The lift would increase and the aircraft would climb as a result of the increased lift force or acceleration. Therefore, constant altitude is accomplished by reducing the angle of attack. We can do this by lowering the nose. Similarly, as velocity decreases, the nose is pointed upwards.
Induced drag is a byproduct of lift and resists the forward movement of an aircraft through air. At high angles of attack, the high pressure air below the wing likes to swirl around the wingtip towards the low pressure air above the wing. A twisting vortex of air forms behind the wing, deflecting the airflow downwards. We call this downwash. An inclined local airflow is created, the average of the relative airflow and deflected airflow. This results in a lift factor, tilting backwards. This is induced drag.
Parasite drag refers to the drag that is not associated with the production of lift, such as form drag. This is generated by the aircraft's shape and the airflow around it. The solution is to streamline as many parts as possible. When the air has to separate to move around a moving aircraft and its components, it eventually rejoins after passing the body. How quickly and smoothly it rejoins is representative of the resistance that it creates, which requires additional force to overcome. Skin friction drag depends on the quality of the plane's surface that allows airflow to pass over it. A laminar flow occurs when airflow passes over smooth surfaces, but introduce wind, ice, or dirt, and a turbulent boundary layer is formed, forcing the airflow to break away sooner, resulting in skin friction drag. For this reason, the surface is finished with a smooth finish. The aircraft surface should be maintained like so to decrease drag. Interference drag and form drag are together known as profile drag. Now, sometimes, the airflow around the wing may flow faster than the airflow around the plane's body. Interference drag occurs when they clash within the space they share. Induced drag is most significant at low air speeds and high angles of attack. An increase in airspeed increases parasite drag. The point where induced drag and parasite drag meet is known as VMD. Any change in the airspeed, or AOA, at VMD will result in the increase of total drag. Hence, VMD is always achieved at the optimal angle of attack, that is, 4 degrees.
To overcome this drag, we need thrust. Thrust is defined as the forward force produced by the propeller or jet engine. Propellers are powered by the aircraft's engine to produce thrust. Jet engines work on the same principle as when you blow up a balloon and you let it go. The air comes out the back and the balloon moves forward. For an aircraft to start moving, thrust must be exerted and be greater than the drag. As long as thrust is greater than the drag, the aircraft can continue to move and gain speed. To maintain a constant airspeed, thrust must be equal to drag. In level flight, the engine power is reduced, lessening the thrust and slowing down the aircraft. As long as the drag is greater than the thrust, the aircraft continues to decelerate. As the aircraft slows down, the drag force will also decrease to a certain extent. Likewise, if the engine power is increased, thrust becomes greater than drag and the airspeed increases. When drag equals thrust, the aircraft flies at a constant airspeed due to the net force being zero. The pilot coordinates the angle of attack and thrust to maintain level flight. As the airspeed varies due to thrust, the angle of attack must also vary to maintain level flight. Where the airspeed is high, the angle of attack must decrease to maintain level flight. Similarly, where airspeed is low, the angle of attack must increase. Pilots must take care at low thrust settings and low airspeeds so as not to exceed the critical angle of attack.
Failure to do so will result in stall.
The forces on an aircraft don't share a common point. The centre of pressure lies a short distance away from the centre of gravity. Since lift and weight do not act on the same line, they make up what is known as a couple. This couple has a turning effect on the aircraft, pitching the nose downwards. In addition, the line of action of thrust is normally below the drag's line of action, because engines are in position midway or lower on the aircraft body. The thrust and drag forces constitute an opposite couple, the effect of which is to pitch the nose upwards. Thus, the two couples generally cancel each other out.
In summary, weight pulls the aircraft towards the Earth's centre and opposes lift, the effect of forcing wind over the airfoil, creating pressure difference and lifting it. Thrust is the force created by a propeller or motor and drives the plane forward, and is opposed by drag, a byproduct of lift, but also produced by friction, disruption in streamlining, and an interference of airflows travelling at different speeds.